Hey, what's going on, guys? It's Digital Dawn here, back with another video. Today I'm going to be making a video on how to do the maximum level sum of a binary tree. I think this is a really good question because it gives you a good understanding of level order, as well as I know it's a Google question that they ask a lot and like they're known for asking. So I just thought it'd be a really good video to make or a really good question to make a video on. But yeah, anyway, so let's dive into it. So let's start by reading the question. So basically, what the question is saying is, given the root of a binary tree, the level of its root is 1. So that means this is, sometimes like they might say that the level is 0. It's always either 0 or 1. In this case, they're saying it's 1. And then its child is 2 and so on. And basically what it wants you to do is return the level that has the largest sum. Okay, so this level here is level 1, has a sum of 1, because there's only 1 there. This level 2 has a sum of 7 plus 0, which is 7. And then level 3 has a sum of -1, because 7 plus 8 is -1. And yeah, that's exactly what we see here. So if you do all those calculations, you see that level 2 has the greatest sum, so you return level 2. Okay, so basically the best way to solve this is just to go through and calculate the sum of all the levels, okay, and then keep count of which level you're on and which level has the greatest sum. Okay, and so first off, what you want to do is just calculate the sum of each level. And the way to do that is the best way to do that is by doing level order. Okay, at least a pretty good solution for this. I'm not sure if it's the best solution, but I think it's a really good solution. Okay, and so first thing we want to do is just base case. So if the root equals null, so if like there's nothing in the tree, then we just return 0. All right. Believe the number of nodes in the tree. Okay, well actually it says that we'll always technically have at least 1. So in that case, it's fine, but we'll still, yeah, so this won't happen, but it's still fine just to have that anyways, okay? And then next thing that we're gonna want is we're gonna want something called max sum. And we'll set this equal to 0. Sorry, actually, for this one, what we want is we actually want to set this equal to the smallest like possible value, which you can get just by doing this integer.min value. And so the reason we set it's just like the smallest possible value is just because then like when we're always comparing our other like sums with it, if we set it just equal to 0 and like we had a sum that was negative, then it wouldn't work. So usually like when you're iterating through like an array or anything like that and you want to find the largest value, you always set like your check, like the integer that you used to check, you usually always want to set it to integer.min value. Unless all of them are positive, then you could just set it to 0. But in this case, we know that we can have negative integers as you see here, so that's why we do that. All right, okay, so next what we want is we then want to create a queue. Okay. New linked. Okay. Then we also want here. I should put this here into level 0 and max level equals 0. Okay, so I'm just gonna go through, I'll just write the code pretty quickly, and then I'll go through and walk like line by line, like why it works. Okay, so queue.add, so we wanna add the root to our queue. Okay, then usually with queues, and same with stacks, when you iterate through, it's pretty common to use a loop, or a while loop, and usually you do like while queue is not empty, so this will loop through while it's not empty, okay? Current sum equals 0, and then int size equals. Okay. Okay, so write the for loop, iterate through the size. Okay, we then check the left and the right, right. If they're not null, we add them to the queue. Okay, and then last thing that we do is we then increase our level. Sorry, outside the for loop. Level plus plus. If you guys want to just skip to the part where I explain it very well, just skip a little bit ahead to the point where I'm done writing the code. Check if the current sum is greater than the max sum. Max sum equals current sum. Max level equals level. And then we return max level. Okay, just quickly run it just to make sure. This is not supposed to be integer. My bad. Sorry. Forgot, really important. I just forgot to remove from the queue. So that's why I was just infinite loop there for a sec. No problem though. This should work. Yes. Okay, so let's go by and explain how this works. Okay, so first thing that we do is we add to our queue the root, okay, which in this case is 1. So our queue has 1 in it, okay, and then we go into this and we loop while the queue is not empty. Okay, so right now the queue has 1, so it's not empty. Okay, we set current equal to 0 and size equal to the size of the queue. So our queue is 1, so the size is going to be equal to 1 on the first loop, okay? Then what we do is we enter this for loop. We say for I equals 0, I is less than size, I plus plus. Okay, so right now size is 1, so this is only going to execute 1 time, okay? And one thing that you'll notice is that size is always going to be equal to the amount of nodes on a level, okay? So that's how we're able to determine if we're on a new level or if we're not, okay? Because once we enter this for loop, we're in a new level, and the second we exit it, we've now entered into a new level, okay? So that's why we increase the level there, okay? So what we do is we then take our queue, we look and we say, okay, does it have a left? Left is not equal to null, so we add it to our queue. Okay, so after that, our queue is now going to be 1, and we just added the left, so it's going to have 1 and 7. Okay, and then we're going to check the right, same thing, but now our queue is going to have 1, 7, and 8. Okay. Then what we're going to do is we're going to set the current sum, which is 0, equal to the queue.remove. Okay. So now our current sum equals 0, and our queue is now 7 and 8 because we just removed 1 from it. Oops, 1. Okay. We then go back after the for loop, and now this is no longer true. Okay. So we're done. Current sum equals 1. Increase the level by 1, so level is now 1. We then check the current sum with the max sum, which we set to like some super large negative number. Okay. 1 is larger than that super large negative number. Okay, so now max sum equals 1. So far, our largest sum is 1. And because this is true, we then set the max level equal to the level that we've searched. So now max level equals 1. Okay. We now go back up to our while loop and we say, is the queue empty? Okay. So let's go through and let's reset these. Okay, and our queue is now 7 and 8. Sorry, 7 and 0. I'm not sure why I was saying 8. 7 and 0. Okay. So now we go, well, the queue is not empty. Again, we set the current sum equal to 0. So the current sum represents the sum of all of the nodes on that level. Okay. And the size is equal to the current size of the queue. So right now our size is 2. Okay, and there happens to be 2 elements on the second level. So this is going to loop through 2 times. Okay, so first we check this. Say, well, it's not equal to null. So we're going to take our queue and we're going to add 7.left, peak.left. Okay, so now our queue is going to be 7, 0, 7. Okay. And then we're going to take our queue and peak at its right. Okay. Which is, when we peak, we're looking at 7, so 7's right. It's not null, it's -8, so we add it to the queue. 7, 0, -8. Sorry. 7, 0, 7, -8. Okay. We then remove this from the queue, 7, and we add it onto our current sum. So our current sum after that is then current equals 7. Okay. Now go back up to here. And okay, and we remove, so before that, Q is that. Now the Q is this. Okay. We then go back up. And so remember how our size was 2? So we have to do this twice. So we've done it once. Now we're doing our second time. So we say, okay, check this one, which was 0. We're checking the first one. We're checking its left, null. Okay, do nothing. So our Q at this point is this. So 0's left is null, so it doesn't add anything. We check 0's right. It's also null, so we don't add anything. So our Q stays the same as this. Okay, we then take the current sum, plus we remove this, and we add it to that. So this will stay the same because 7 plus 0, it's still 7, but we then remove this. So we have 7 and this, okay? Now we've gone through the for loop twice. So we go here, we increase level. So level started at 0, we added 1 to it. Now we added one more time to it. So level at this point, level equals 2. Okay, we then check our current sum, which was 1 from the last time. We then check, so our current sum is 7. Our max sum is 1 from the last time. 7 is greater than 1, so we change them. And then we change our max level equals to the current level, so max level equals 2. Okay? Then reset this again. Now our Q is going to be 7 and negative 8. Okay, and it's the same thing as the last time. Just add the 7, the 8, check, current sum 0, size 2, go through it twice. This isn't going to add anything to the Q. This is not going to add anything to the Q. After that, our Q is how it was before. Okay, except this time, current sum is 0 plus 7. So after that, current sum, so our Q would be just negative 8. And our current sum equals 7. Go through here one more time. Nothing, add nothing, add nothing. Q up to that point, negative 8. We then move at negative 8. Our Q is empty. And then we do plus negative 8. Okay. Then increase the level. Level equals 3. But this condition will not evaluate to true because current sum equals negative 1. So we will not increase the max level. Okay. We then go back up for a while loop, and we see that the Q is empty. So nothing happens, and then we return the max level, which we said was 2. And boom, there you go. So that's a little level order traversal there and solution. So yeah, I recommend kind of learning level order. It's pretty useful and not super complicated. And it's basically using this for loop here that helps us determine when we're on a new level or not. But yeah, so we can go ahead and submit that. And yeah, so as you can see, it's not the fastest. It's not as fast as these ones. And it's not the best in terms of memory, but it's a pretty solid solution in my opinion. And pretty easy to understand. And it also incorporates level order, which is also a pretty good concept to understand. And yeah, anyways, hope you guys enjoyed the video. If you did, leave a comment, leave a like. If you leave any questions you'd like me to do in the comments, I'd be happy to do them. If any questions, let me know. And yeah, good rest of your day. Bye, guys.